Hey everybody, it's Cal here from Wise Guys Tutoring, back with a new video. I want to talk to you guys about fractions, and hopefully you want to talk about that too, and that's why you're here. So first, what I want to do is tell you how to find the fraction of a number. Second of all, how to find equivalent fraction, and lastly, we'll see how to simplify a fraction into the simplest form. So let's not stall any longer, let's get started. First, before we get started, I just want to tell you about fractions themselves. Fractions are actually, a form of division. So when you see 2 over 3, this is the same, it has the same value as 2 divided by 3, right? But 2 divided by 3, if you would put that in your calculator, gives you 0.6 recurring, 6 forever. We prefer to write it with a bar, with a dot, some people. So in some cases, you might want to use the number, the decimal, but in a lot of times, this guy's a lot more practical, right? It's a lot cleaner to write 2 over 3 rather than 0.6 recurring. As you'll see, fractions do have uses, even though they may seem useless to you now. Okay, so like I said, let's talk about, first of all, how to take fractions of a number. Fractions of a number. Since they are a division, we can always picture it being a box. So let's say we're trying to find what are 2/5 of 25. 2/5 of 25. What you can do is try to imagine a box, and this whole box is worth 25, 25 marbles, right? And if you were to split this box into 5, let's pretend these are all even pieces. So how many marbles would be in these 2/5 of 25? So essentially what I'm trying to tell you is it's a division. The way you need to start this problem, 2/5 of 25, your first step should be, what is 1/5 of 25? And to find 1/5 of 25, you simply divide 25 by 5. This gives me 5. Now what I have found is that 1/5 of 25 is 5. That means each one of these boxes is worth 5 marbles. Okay? Second step. I don't have 1 out of 5, right? I have 2 out of 5 of 25. Well, that's just double, isn't it? Right? 2 is double of 1. So all I have to do is double the answer that I found earlier. So this will equal 2 times 5 and give me 10. That means that 2/5 of 25 equals 10. Okay, let's try another example. Let's say, for example, I'm trying to find 3/4 of 12. So the first step, like we said, you're just going to try to find 1/4 of 12. And 1/4 of 12 is just a division of 12 divided by 4. This is pretty simple for us. 3, right? The second step is we weren't looking for 1/4, were we? We were looking for 3/4. Now, since 3 is 3 times as big, all we have to do is get our answer and multiply it by 3. So 3/4 of 12 is 3 times 3. And the answer I get is 9. So 3/4 of 12 equals 9. So that's how you find the fraction of a number. You don't really need to get into the multiplication of it. We might do that in the next video. But for now, you have 2 steps. Firstly, recognizing that this is a division. 1/5 of 25 is just 25 divided by 5. That's pretty easy. And then we look to the numerator to see what we should multiply by. So I don't have 1/5, right? I had 2/5. So I simply multiply my 5 that we found earlier by 2. And we did the same thing with the 3/4. So I don't need to find 3/4 of 12. I just need to find 1/4 of 12, which is 12 divided by 4. After that, once we have our answer of 3, since we have 3/4, we multiplied it by 3. And that gave me the answer of 9. Next thing I want to talk about is equivalent fractions. So I'm sure you've come across that word before, hopefully. And it sounds a lot like equal, right? Because that's what's implied. And I'll show you why. When we talk about 1 over 2, 1/2, and let's imagine this box here, and we split it in two. So 1 of 2, 1/2, means 1 out of the 2 parts, right? And let's imagine this same box is actually split into 4, and I take 2 out of the 4 pieces. So 2 out of the 4 pieces looks kind of like this. Essentially, it's the same size as that first piece, right? And I can do it with all kinds of fractions. Let's say 3 out of 6. So if I had that same box and I split it into 6 pieces, let's imagine that they're even, and my hand is steady. So it would be these 3 pieces here, which is actually the exact same area. So that's why we say that these fractions are equivalent. Now we've seen how to do it, visually with a box, but what does it mean algebraically? Well, basically it means that you have to multiply the top and the bottom by the same value. So in this case, we multiplied the top and the bottom by 2, and that gave us an equivalent fraction. In another case, let's make it pink or something, we multiplied the top and the bottom by 3. And you can go on and on with this, and you can take you can multiply each number by 10 if you like. As long as you're multiplying top and the bottom by the same thing, it's going to work out to an equivalent fraction. So this would equal to 10 over 20. And indeed, 10 over 20, if we were to draw a box of 20 pieces and color 10 of them, it would equal exactly 1/2 of the box. So that's how you would find equivalent fractions. Okay, as long as the top and bottom are multiplied by the same, then you will end up with an equivalent fraction. In fact, dividing would also work, right? If you were to go from the 10 over 20, and you would divide by 2, for example, and divide by 2 on top and bottom, then you would end up with 5 over 10, and these are also equivalent fractions, so it works both ways. All right. One question you might come across is something like this. They might ask you, if 3 over 5 has an equivalent fraction with a denominator of 15, then what would the numerator be? Right? If these are equivalent, so essentially they are of equal value, then what would your numerator be? Well, in this case, all you have to do is sort of the same thing we were doing in reverse. You need to figure out how you got to 15 from 5 using some kind of multiplication, right? And how do you get from 5 to 15 is by multiplying by 3. You got to do the exact same thing on top to the numerator. That means you need to multiply by 3. And that's all you do. Now we found our numerator must equal 9. Therefore, 3 over 5 is equivalent to 9 over 15. So in case you're faced with a problem, a question where they're asking you to find an equivalent fraction, but you're bounded by a specific numerator or denominator, then this is what you have to do. You have to find out how did you get to it through a multiplication, and do the same thing to your numerator. If it was the denominator, we can use another example, of course. We can say, how about 2 over 7 equals 4 over something. So we would have to do the same thing when we use green or something for the numerator. So how did we get from 2 to 4? We multiplied by 2. That means you'd have to do the exact same thing to your numerator, the 7, to find the bottom one. And the denominator in this case then will be 14. And the numerator in this case will be, and the denominator in this case will be 14. And there you have it. So that's basically it for equivalent fraction. We can move on now to simplifying fraction, which is basically the same thing but in reverse. Now let's get into simplifying fractions. So whenever you're working with fractions, you are most likely going to be asked to find the simplest form. That's how they say it. They say the simplest form. And what that means is nobody likes to see 14 over 28. Okay, because this can be simplified. Remember, when we were talking about equivalent fractions, you can multiply top and bottom, but you can also divide. So we can divide this by 7 and divide this one by 7 as well. And the equivalent fraction in this case will be 2 over 3. And this is what people want to see, right? Your teacher will want to see the simplest fraction. Now, how do we do that? How do we do that in a systematic way? The best way I can tell you is this. If you have two numbers, let's take something easy like 4 out of 8. The easiest thing to do is try to think of a factor, a multiplier that can give you 4 that can also multiply to give 8. In this case, you might have thought of number 2 or number 4. Let's say we talk about 2. That means the 4 can be rewritten as 2 over 2. While the 8 can be rewritten as 2 times 4, right? These two, if you've seen our algebra video, these two will cancel out, right? Because one is multiplying and one is dividing. So top and bottom cancel out. And what I have remaining there is 2 over 4. Now, are we done? Not quite, because we can still find a factor, a multiplier that gives me 2 and it also multiplies to give me 4. And that would be 2. So this is like 2 times 1, and this is like 2 times 2. Again, we're going to cancel out those two guys, top and bottom, and then I'm left with 1/2. Now 1/2 is pretty much as simple as you can make it. Okay, that's as low as we're going to get. So let's try another example, because that's the best way to do this. So how about 21 over 33, for example? So what we need to do is find a number which multiplies to give me 21, and it also multiplies to give me 33. There's not a lot of options, right? 21 only has factors of 1, 3, 7, and 21. So you may have noticed that 3 would work, right? 3 can multiply to give both. So we'll say 3 times 7 and 3 times 11. 3's are going to cancel out, top and bottom, and that leaves me with 7 over 11. So in some cases you may get some strange fractions like 72 over 264, something that won't be as obvious as the examples that we've done. What you need to do is use the prime factor method. So what we're going to do is put 72 here, and we'll do 264 in a minute. You need to break this up into its prime factors. So we need to find two numbers that multiply to give 72. So we can say 2 times 36. And 2 is a prime, so we'll leave that alone. 36 can be broken up into two numbers. For example, 4 and 9. The 4 can be broken up into 2 and 2. The 9 can be broken up into 3 and 3. And that's pretty much all she wrote. So now let me gather all these prime factors over here. Got a 2, another one, a third one, and we got 2 3's, right? Let's try to do the same thing with 264. So 264, I like to start with 2 because it's pretty straightforward. 132, again I'll go with 2 on this one, so this is 66. And again I can go with 2 and 33, which can be broken into 3 and 11. So let me circle those guys in orange, okay? So these are my prime factors. If you're wondering how I did that, we're going to make another video about that soon. So don't worry. So let's take our weird fraction, which was 72 over 264, right? So what I've done now by breaking it up into the prime factors, all I'm saying is that this 72 can be rewritten as 2 times 2 times 2 times 3 times 3. And that's true, if you don't trust me, you can do the multiplication. And the bottom here, the denominator, 264 can be rewritten as 2 times 2 times 2 times 3 times 11, right? So same as we were doing before with the simplifications, anybody on top and on bottom, each pair can get canceled out. So this 2 can go with that 2. Wouldn't I use different colors? This 2 with this 2 in the pink. How about some orange here? This 2 with this 2. Some green. This 3 with this 3. And all I have left is 3/11. And that's as simplified as it can get. So 72/264 can be rewritten as 3/11. That's all it is when you're doing simplifying fractions. So normally what you'll have is something probably, you know, closer to the one on the left, where you'll be able to, you know, figure out a common factor for the numerator and denominator and then try to rewrite it and cancel out. You can probably do that with the 72/264. It's just, you know, it might be a little longer. This way may be a bit faster. I'm just giving you all the methods that you need to make sure that you're able to simplify any fraction you have to. So I hope you enjoyed this video. We're going to do another one next on adding, subtracting, multiplying, dividing, and comparing fractions. So you'll use, you know, these tools that you used here, these skills that you learned. So please, as usual, like, subscribe. If you have any questions, comments, feel free to write to me, and we'll see you in the next one. Thanks, guys.